All right, so here's the second circuit that we're going to be going over today. All right, or the second biasing circuit. So let's look at what we have here. So a couple of things happened from the previous video. One, I flipped the diode around, okay? And I didn't finish drawing the diode. All right, so one, I flipped the diode around, and two, you notice that the power supply has flipped around. Okay? So basically what we're going to do is we are going to want to lock the voltage in the negative direction now. And I'll explain why we turn the power source around in just a moment. So notice that now that's my negative. And that's my positive. So let's label our upswing and our downswing. On the upswing, the diode's cathode is positive. So that means that I will be reverse bias. And on the downswing, the positive is ultimately tied to the anode, so that means I'm in forward bias. So a couple of things happened here, okay? So I have turned the power source around. So if you take your meter, the proper way to measure this is your meter is always going to go to reference, which is right here. And then your positive lead would go here. Remember what I told you in the previous video. If this is the red lead and this is the black lead, I'm technically measuring the power source backwards. So what is your meter going to display? A positive or a negative voltage? Negative. Okay? A negative voltage. And that's again because black always goes to reference. But if you look, the positive is now tied to the reference point. So that means that when I physically take a meter and measure across this power source, it's going to read negative. Okay? So I have a negative 3.3 sitting at the anode. So let me ask you a question. It's on the downswing that we become forward biased. On the downswing, what is the polarity of your voltage? It's traveling in the negative direction. So that lock, that forward bias lock, is actually negative 0.7 volts. Because remember, so let's draw it. So we'll give this 15 volts peak, okay? So we have a positive 15 and a negative 15. So on the upswing, we're reverse bias, so it's just an open. But on the downswing, all right, on the downswing, we're traveling in the negative direction. So if current's traveling in the negative direction, per se, then that's going to be a negative 0.7 volt lock because this is technically like a negative clipper. So what is negative 3.3 plus negative 0.7? That equals negative 4. So what that's telling me is that this is going to lock negative 4 volts. That's in the opposite direction. All right, so let's go ahead and let's work it out, and you'll see this is exactly what we had in the previous video, except it's flipped. But instead of flipping just the diode, I did have to flip the power source, so that way when I measure it, I'll get a negative reading also, because the diode is going to conduct in forward bias on the downswing, so therefore the DC power supply has to read negative. I hope that makes sense. If not, we're going to do a lab with this and you'll see it even more plainly once we do the lab. Okay? So, real quick, on the upswing, we're reverse bias. So it's easy, just like the last video when we're reverse bias. This is open. So it's going to take and it's going to split this 15 volts, 7.5 and 7.5. And if this reads 7.5, this is an open, so this is going to read 7.5 also. So go through and draw 7.5 on all your upswings. Now, on your downswing, hope that didn't confuse anybody, sorry I left that drawn. So now, on the downswing, I'm forward biased. But remember, I have this 3.3 volt extra source here. So that means that I'm going to lock at -4 because it's enough. Because if you treated it just like a series circuit, that'd be 7.5, 7.5. 7.5 volts is plenty enough above 4 to lock. So that means that across the diode, -4 volts, -4 volts, and then VR1 equals VS minus VD. If that confuses you, it's okay. You're just in the downswing, so you can just write just the number. I was just indicating that because we are going in the negative downswing. So VS, which is 15, minus 4, okay? So we got 15 minus 4 equals 11 volts. So VR1 is 11 volts. So now go and label all your downswings. All right, and then across the diode, we have that nice -4 volt lock and that nice -4 volt lock there. So, besides some different numbers, because I changed the source up a little bit, this is exactly what we saw in the previous circuit. It's just everything is flopped. Now, I'm locking that voltage, or biasing it a little higher on the downswing. So the -4 volts on the downswing instead of on the upswing. Okay? So that's all there is to it. Again, just remember, polarity is important. Alright? And again, I read -3 volts because if red leads here and black leads here, I'm actually measuring that DC power source backwards. So the meter will indicate negative. And since the forward bias lock is on the downswing, that's a -0.7. So -3.3 plus -0.7 gives me -4. Okay? All right. So again, if you have any questions, please let me know. And we will see this in a lab later this week. So Wednesday and Thursday labs, we'll be doing some Zener labs and then one biasing lab. Okay? All right, so one more thing that I wanted to mention. I have moved the test to next Monday and Tuesday since we were out Monday and Tuesday this week. So we're going to make sure that we get through these labs so you can see it. Test Monday and Tuesday, and then Wednesday and Thursday next week, we're jumping straight into rectifiers. Spend about a week or so on those, and then finish up the semester with amplifiers. Okay? All right, so y'all have a good rest of your day, and if you have any questions, let me know.